In this problem, we'll look at motorboat travel. A motorboat traveled for 2 hours with an 8 km/h current. The return trip against the same current took 3 hours. We're asked to find the speed of the motorboat in still water. We'll approach this problem using our five-step problem-solving strategy, and the first step is to familiarize ourselves with the situation. We want probably first of all to read the question again carefully and notice that we have two motion situations. One is with the current, and that means in the same direction as the current, so the current will actually be helping the speed or moving the motorboat along faster than it would go in still water. And the return trip is against the current, so the motorboat has to work against the current, so it will take longer. As you can see, it took 3 hours to go against the current and 2 hours to go with the current. When we familiarize ourselves with the situation, we'll want to define some variables. Since we're looking for the speed of the motorboat in still water, we'll let R equal that speed. And I'll make it real clear that this is the speed of the motorboat without current or in still water. And this would be in km/h. Then the speed with the current would be R plus 8, and the speed against the current would be R minus 8. Now we don't know how far the motorboat traveled either, so we'll let D equal the distance it traveled. Now, as with any motion problem, this information can be organized into a table to help us translate the problem to mathematical language. In a table, we let the columns stand for distance, speed, and time. And then we look at the two situations of motion we have. In this case, with current and against current. And we can draw in a table with 2 rows and 3 columns. And then let's fill in what we know. Well, we're given the times. If we look back at the problem, we see that the motorboat traveled 2 hours with the current, 3 hours against the current. So let's fill in that. 2 hours with the current, 3 hours against the current. When we're familiarizing ourselves with the situation, we let D be the distance, and a key thing to note is that the distance is the same in both situations. So we'll let both of these be D. And then we saw that the speed with the current was R plus 8, and the speed against the current was R minus 8. Now once that's filled in, we can use the motion equation D equals RT, or distance equals rate times time or speed times time, and read right across these rows of the table to create 2 equations and to translate into 2 equations. We would have then, as step 2, translate, we would have the equations D equals R plus 8 times 2. This is the situation with the current, and D equals R minus 8 times 3. This is the situation against the current. Now that we've translated to a system of equations, we can solve that system as step 3 of the problem-solving process. To solve, notice that D equals R plus 8 times 2 and D equals R minus 8 times 3. So I can substitute R plus 8 times 2 for D into this equation. And I get R plus 8 times 2. Since that equals D, I substitute that in the second equation for D. So that equals R minus 8 times 3. And now I have an equation with just R in it. To solve, I multiply. I get 2R plus 16 equals 3R minus 24. I subtract r from both sides and I get 16 equals r minus 24. And I add 24 to both sides to get that 40 equals r. Now before we move to the next step, check, I'm going to go back and look at the problem one more time. And this is something you should always do at this point. What were we asked to find? We're asked to find the speed of the motorboat in still water, and that is r. But sometimes you may have defined a variable another way. Perhaps in this case we ended up solving for d, and we'd have to go back and find the actual thing we were asked to find. But in this case we did find the speed of the motorboat in still water, so we go to step 4, which is to check. Now when the r is 40, the speed with the current would be 48 kilometers per hour. The speed against the current would then be 40 minus 8, or 32 kilometers per hour. The time with the current was 2 hours. The time against the current was 3 hours. Now, if the speed times the time gives us the distance 96 kilometers with the current, speed times the time gives us the distance 96 kilometers against the current, we have a check because the distances are the same. So we can state that the speed of the motorboat in still water is 40 kilometers per hour.